All right, so I got to remember there was a couple things I wanted like some bookkeeping things before we dove right into the lesson. Let me think here. So the first thing is, as you can like see, I've now been making these assignments like on my end. I actually make them not just like an assignment. I make it like a Kami assignment. You probably don't see the difference really. I don't know, maybe, but so that means I have to attach the PDFs. So, but at this time, I'm going to go with that you can still attach photos. If like you can totally ignore the PDF attachment that's there. And what you can do is just still attach like your own photos, which is what I highly recommend doing. But, so there was that. Oh, and there was one other thing, okay? There's one other thing. So listen to this, please, carefully, and I hope this makes sense, and I hope you take it to heart, okay? Obviously, one of my big frustrations is, people not turning things in on time, you know what I mean? It's frustrating for me. Like, for you, all it really means is, like, you lose points. But, look, maybe just some other thing to, like, I don't know, some other way to elaborate on that. This does get complicated with like when these things are due. You know what I mean? Like I try to make the due date, 2 or 3 days, sometimes more than that, like days in the future. So the due dates are obviously, not like the same day, right? But don't let that get you into like a false sense of security, because you should still be doing work like basically every day. Don't let yourself get behind. Like you shouldn't get in the habit of like waiting until like the last second, because then things can get all jumbled together, almost like an assembly line that gets all jammed up, and then everything starts falling off the rails, kind of thing. So I don't know. I don't know if that made any sense, but like don't let the due dates completely dictate your schedule. If on Monday, like this very week, on Monday I assigned 2.5, you should be probably doing your 2.5 stuff like on Monday. Like don't wait until like this is due tonight. Don't wait until Wednesday. You know what I mean? Like we teach it on Monday. You should probably do this on Monday. Anyway, I don't know. Hopefully that made some kind of sense. Well, I should have shared my screen already. So everyone, okay. So 1, 2, 3. Did I miss anybody for attendance? Jesselyn, Jack. I'll look a little bit later. But all right, I'm going to present my screen. Let's see. Jesselyn, can you see? Wait. Jesselyn, can you see my my document camera, my paper?
Yeah.
Yeah. Okay. Gang, before I jump right in, like, are there any questions about like anything this week so far? Like 2.6, 2.5. Any questions about anything so far? Like you were struggling with anything? If so, I mean, you could email me or private message me on that assignment, or whenever. Like I'm available to help one on one. But if you're struggling with something, then let me know. Most of these Google Meets are reserved to like kind of go over like new material, but which maybe we'll do that on Friday. Like maybe on Friday we'll slow down and just kind of do. I don't know. We'll play it by ear, but please let me know if anything is you're struggling with that. But here we go, 2.7. So if you don't have this paper out, then please get this out quick. Multiplying special cases. Here we go. So the really good news here is that this is essentially the same thing we were doing last section, which of course is section 2.6. See for yourself. All right, so let's see here. Connor, you're usually pretty trustworthy to put you on the spot here. How do we do this multiplying, Connor? This is basically what we were learning new in section 2.6.
You would use the distributive property to multiply them together.
Can you be you're right, obviously. Can you be a little more, so how does the distributive property work here? Can you be a little more specific?
I would do x squared minus 16, I guess.
And that's all?
Well, that's the answer.
Okay. Connor, you're missing a couple things actually here.
Sorry,
That's okay.
Multiply x times x and 4 times 4.
Yeah, okay.
Well, or negative 4, depending on whether you want to do it that way or not.
But check it out, and don't feel too bad, Connor, because this was from 2.6, which was the very recent section. I don't know if, and again, I don't want to repeat myself and be like a nag, but 2.6 isn't technically due until, I don't know, tomorrow. I don't know. But you probably, if you're keeping up the way you probably should be, 2.6, maybe you should have been working on that, I guess yesterday, huh? So there was a video posted yesterday. So you want to, so anyway, if you didn't get a chance to look at that yet, the good news is we're going to be doing the same kind of thing. So here's what you have to do when it's a bubble of two terms times a bubble of two terms. This x gets distributed through the whole second bubble. So not only are you doing x times x, but you also have to do x times negative 4. So, yep, Connor was right about the x squared, but then you also are going to have negative 4x. Then you not only distribute, the 4 not only gets multiplied to the negative 4, but this positive 4 gets fully distributed through that second bubble. So you also have to do positive 4 times x. So that's plus 4x and then the negative 16. All right, so again, that's you got to do all of that distributing. Now, like I said in the video yesterday, a lot of teachers and textbooks summarize this exact situation with the distributive property as FOIL. Jack, do you remember what FOIL stands for? Did you get a chance, or do you remember from maybe I don't think I covered this last class, but in an integrated one. Jack, do you know what FOIL is all about? The acronym?
No.
No? All right, well, this, again, what Connor was talking about with the distributing, that's basically what happens. We have to distribute the x, and then we have to distribute the 4. But this is it's a very cute, very convenient way to summarize it. The F stands for, firsts. And then the O stands for outers. And then the I stands for inners. And then the L stands for lasts. Because that's kind of what we just did. We multiplied the firsts in each bubble. Then we multiplied the outers, the ones that were on the outside, the outers. And then we multiplied here, look here, the inners, the inside ones. And then we multiplied the lasts together, the last term in each bubble. But again, it was really just the distributive property, okay? Now, again, this happened a lot in yesterday's section video of 2.6. These two terms combine, and let's see, Mackenzie, do you know what negative 4x plus 4x is? You're close, kind of. Negative 4 plus 4 technically is what? Do you know, Mackenzie? I think you get it, but because okay, Mackenzie, like what is? Forget about the x for a second, Mackenzie. What's negative 4 plus 4?
8.
Well, I think I'm confusing you now. Negative 4 and then a positive 4 make 0. You know, which I think that's why you just said x a second ago. But, you know, if this is like technically, let's write that down actually, at least one time. So this would technically be like 0x, but I think this is what Mackenzie was slightly confused about in the first place. 0x, that's not x, that's gone. 0x is like, it's basically 0, you know? So negative 4x plus 4x, that basically cancels out. And the final answer, the cleanest way to write that, the bestest way to write that final answer is x squared minus 16. All right? Now, let's see what happens here. So again, same thing, a binomial times a binomial. We have to distribute the k, right? We distribute the k, because again, it's not like there's one thing out in front here. It's almost like there's a group of two things. So both of them get distributed. And then the negative 7 also gets distributed. And look, see again, plus 7k, minus 7k, those basically add up to 0, like just basically 0. And so this final answer is k squared minus 49. Okay? How about this next one? So, Dakaya, no rush here. Like you can gather your thoughts and get caught up here. But Dakaya, in this next example, you know, what's the first thing I do, or what do we do?
Don't we distribute first?
Yep. And so what are we going to distribute? The 2x? So we got to do 2x times 2x to get 4x squared. Okay? 2x times 2x, 4x squared. And then we have to do the 2x times negative 3, which is negative 6x. But then we also have to distribute the 3 to get plus 6x minus 9. Because remember, distributing is multiplying. And once again, negative 6x plus 6x, that's literally like 0x, which is just 0. It's gone. And so that's the best way to write our final answer. All right, gang, like take like 15, 20 seconds. Try this one on your own. Go. I'll give you a head start. 3n minus 1 bubble times 3n plus 1. So we should get starting with 9n squared. Aaron, were you able to finish this next step yet?
No.
No? Well, let's talk through it here. So what would be the next term here, Aaron? Do you know? Because we've already done the firsts. Like if you want to go back to FOIL, I can just call this FOIL. We already did the firsts, and that's 9n squared. Like what's the next thing we get here?
Plus 3n.
Perfect. Then what, Aaron? That would have been the outers, I guess. So then what, Aaron?
1 times 1.
Oh, well, you wouldn't be wrong. Like we are gonna do that eventually, but usually we go like in a certain order. You know, especially if you're going by FOIL. So next we would do like negative 1 times 3n, which is like the inners. First, outers, inners, lasts. So the next thing would be minus 3n, because again, it's a negative 1 and a 3n. And then we could do like negative 1 times 1, which is what, Aaron?
Negative 1.
Negative 1, good. All right, so Jesselyn, I don't know if you already had this done in advance, but if not, then we can just do this live. Jesselyn, so then what would be like the final answer? Cleaning this up. Do you know?
Nine n to the second power minus 1.
Perfect. Yep, perfect. Because these cancel out. Which leads me to this question, why do you think multiplying problems like these are considered a special case? It was like literally the title of our paper, 2.7, multiplying special cases. Like I was saying, it was just the same thing. It was the same. So this stuff, like multiplying a binomial times a binomial, that's a lot of what section 2.6 was, But why was this like a special case? Does anyone think they know why we called this like a special case? Just kind of unmute and say it out loud. I don't care who it is. Does anyone know why this would be like a special case? No, that's okay, because what can we say here? Because the middle terms, in other words, the outers and inners, those middle terms cancel out. Like, that's what makes this a special case. The fact that your final answer is only going to be a binomial and not a trinomial. Like, that's it, It's not that special, but it's kind of special when you have these middle terms like literally cancel out, and so your final answer is that. Like, that's really what makes this a special case. Okay? Any questions or comments about that? As I make sure no one else has joined in here unannounced. Like William. Lord William, His Royal Williamness. Actually,
What?
Nothing. Bad joke. Lords aren't actually like kings and queens, so bad joke. As a reminder, gang, if you pop in late, I might not notice. So, like, shoot me like an email or something. Just, I don't know, or whatever. So, like, let me know in case I don't see you. All right, to the second page. All right, so I don't think we need to kind of drag our feet through this. Flashback. Flashback questions. Explain what 5 to the second power means. Okay, that means 5 times 5. That's what a power of 2 means. Negative 3 to the second power. That was bad handwriting. Negative 3 times that's what it means, X to the second power, that obviously means x times x. Okay? Number 4. Let's slow this down. Trying to think what have we learned so far? Okay. I think I'm good. So what does this actually mean? I don't want to teach things out of order, so I just got to be a little careful here, but you don't. So never mind. So what does this mean? 4x to the third times y. This whole thing squared, what does it mean? Well, it means 4x cubed y times 4x cubed y. you know, which we could then, continue. Just like this is now, oh, this is just 25. Oh, this is just now positive 9. This is, of course, well, x squared, duh. We could, like, continue if we wanted to. I don't want to right now. But we could, you know what I mean? Now that we're doing, like, so what is 4x cubed y all squared? Like, we could keep going with this and actually finish it off, you know what I mean? But that's what this means. Whatever squared, means whatever times whatever. Like I could go silly and just say like applesauce squared is applesauce times applesauce. As much sense as that would make. So down here, okay, here's the other, special case, right? I guess we could say like the other quote-unquote special case. So in this lesson of section 2.7, I wanted you to see this kind of special case and then this other kind of special case. So what do we do if we have to simplify this squared? William, what do you think the first thing we should write down is? Like, or what I don't know, how do we start this off, William? Do you know?
Distribute the exponent.
Okay. I don't blame you too bad for saying that. Like, don't feel too bad for that. That's actually wrong. But again, like, that's kind of why we're doing this right now. You know what I mean? That is actually, William and everybody, if I had to make like a top 10 all-time list of common algebra mistakes that hundreds and hundreds of students I've had in the past, like they make that mistake, this might be like number 2 all-time bad mistake that people make all the time. Because William, guess what? I wasn't going to go there, but maybe I'll go there a little bit. Like everybody, in this problem, you actually can distribute the 2, the power. Which again, I don't want to open up that can of worms too much right now, but guess what? In this situation, you'd be wrong to just like distribute the power of 2. What you have to do here, people, is actually write this out as x plus 8 times x plus 8. That's kind of why up here I was like, hey, remember, what does this actually mean? 5 times 5. What does this actually mean? That times itself. Even this problem, what it technically means is this times itself. And, William, and again, ultimately what happens after this, it means like you could have basically, like William was saying, whatever happens here, it means like you could have just like distributed the power in the first place. But guess what? That is wrong to do here. And you pretty much need to, that's why a lot of people make that mistake. But this is what you pretty much have to do first. Because now, when it's all written out like this, you'll see that, oh, like we have to FOIL. We have to do all this distributive property, distribute the x and then distribute the 8, which is like all of that FOIL. So this becomes x times x, which, you do get an x squared. And guess what? I know I'm doing this out of order, but I'm trying to make a point here. You do end up with Williams 64, like at the end. I'm not even going to write it yet. So you do have an x squared, and you will end up with a plus 64 here at the end. But you also end up with a plus 8x and another plus 8x when you do the outers and the inners in FOIL. Then you do positive 8 times itself. So you end up getting more than just, distributing the power of 2. Okay? And then what's 8x plus 8x? Do these cancel each other out now? No. It's a positive 8x and a positive 8x. Those actually combine to be 16x. Alrighty? So that's how this works. It's different than up here where it was like just one like monomial being squared. That's essentially the difference. When you're doing a monomial squared, we can ultimately just distribute the power. But if it's like a binomial that's squared, or even like a trinomial that's being squared, you have to do all of this stuff. Like here, you're going to have to go through the motions of distributing all of this, which is like FOIL. Firsts gets us 9x squared. The outers get us what? Minus 15x. The inners, right here, get us, hey, another minus 15x. And then minus 5 times minus 5, positive 25. So the final answer is this. Because these two terms combine, and then nothing else combines with 9x squared. Nothing combines with the plus 25. Alrighty. Alright, so let's say Jack. What's the first step we do here, Jack, in this example?
Distribute the 2x.
Well, what's the very, 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 very first thing I probably want to write down?
Oh, you wanna make 2x plus 1 times 2x plus 1.
Yeah. And then we distribute the 2x. So, let me call on Jesselyn. Jesselyn, just remind everybody, what is 2x times 2x?
4x?
Remember, x times x is x to the second power, right? Yeah. So yeah, 2 times 2 is 4, and then x times x is x to the second. So just again, these are like those little like intricate what's it word? Like those nuanced type things, like the devil's in the details. X times x, x squared. Anyway, then you move on to like 2x times 1, and then 1 times 2x, and 1 times 1. And so your final answer here is that. All right, gang, try this last one on your own quick, okay? Try this last one on your own. I'll give you a head start. About 10 seconds. All right, Connor, were you able to get a final answer for us? What's your final answer?
X squared minus 14x plus 49.
Perfect. Nice work. All right, gang, again, just want to reiterate that, the due dates are the due dates, and I guess ultimately that just means, if you're going to be like losing points or not. But again, like you should be doing stuff like every day, you know, keeping pace, and like that's probably the best thing you can do, because then things don't pile up, and I don't know, because you never know what happens. There's a lot of reasons why you don't want to ever like procrastinate. That's it. Now I would like Jesselyn and Jonathan to stick around for a minute or two, if that's okay. Jesselyn and Jonathan. Or if you think you have any questions, then you can also stick around. But I'll. Did I post the homework already? I think I did. Yeah, 2.7 homework. Yeah, it's not even due till March 8th, but might want to do that today or whatever, or tomorrow. I don't know. But I'll see everyone later. But again, Jesselyn and Jonathan or whoever else, can you stick around for a second?